So we started talking about this example function getInt that allows the user to enter an integer, then asks the user whether that really is the integer the user wanted to enter, and if the user confirms, continues, coming back with the integer, and if the user says no, that's not correct, then allows the user to re-enter the value for the integer. And one of the things that we want to do here is we want to allow the user, well, we want to decide only on the first character of the answer to the question, is this correct, yes or no, whether the value should be accepted or not. But we do want to allow the user to enter more than just a single character. We do want to allow the user to enter no, or yes, or whatever longer version of the answer the user comes up with. Now, in order to achieve that, we need to flush out what remains of the input after we have consumed the first character. So we want the program to consume the first character, a y or an n, and whatever remains in the input up until the end of the line should just be flushed out. How do we do that? Well, we just keep reading individual characters until we hit a new line. Yeah? So if the user entered no and then hit new line, then we're reading the n, of course, because we want to decide based on the first character whether to accept the input or not. Then we read then we continue reading the O, if the user entered no, comma, not really, whatever, maybe a Texan. Then the O, the comma, the space, and so on, all that should be flushed out. That's what this function newLine here does. It is a loop. It declares, first we declare a character variable symbol, and then in this loop here, we just get a symbol. We check whether that is different to the new line. If it is different to the new line, we need to continue. We haven't seen the end of the line yet. Eventually, we will reach the end of the line, and that's when we can stop the loop. Now, what would happen if we didn't have this call to new line in the program? What would happen if we left out this call to new line here? I recommended that you do that over the weekend. Who did? To try that over the weekend? Nobody did? Okay, well, I'm going to explain to you what happens. If we imagine we leave this out. So the user enters, let's say 1, 2, 3 for 123. And then the program says you entered 123. Is that correct? Yes, no. Now let's imagine the user enters no with an exclamation mark and then hits return. What does our program do? Our program continues to extract into the variable ANS. What type is that variable? It's a character variable. So a single character is extracted from the input. Initially, the input stands at this position. Then this n is extracted and is placed into ANS, and that advances this where the next character in the input comes from, that advances it to this character, to the O. Now, if we wouldn't have the new line in here, we would then just continue checking this condition. Is ANS different to a capital Y and ANS is different to a lowercase y? Yes, that's true. So what would happen next? Enter input number. And then we extract into number. So we're trying to extract an integer. But what do we have in the input? In the input, we have the character O. That character cannot be part of an integer. So the extraction operation takes it, sees it is not a digit and puts it back. And the value that we get in number will be 0, I think. You're going to have to try that. I'm not 100% sure. I think it will be 0. Don't rely on that too much. Try it out. So what happens next? The O here has still is still in the input. That's still in the input stream. So when the program prompts, you entered whatever it now got into number. Is that correct? Yes, no. Then we extract here the O into A and S. Yeah? And by extracting the O into A and S, we then advance to the exclamation mark. And then here in the test we see that still is different from a capital Y and it's different from a lowercase y. So we continue doing that. Again, we prompt the user, enter input number, but there's still the exclamation mark in the input. So the same thing happens again. The exclamation mark cannot be part of an integer, and so therefore the extraction into the integer returns right away without having extracted any digits. And we have the same behavior as before, and then we extract one more character into A and S, which is the exclamation mark, which puts the pointer where the next character of the input comes from to the new line. The exclamation mark is different from the lowercase y and different from the uppercase y. So we do that loop again, and now when we reach this extraction here, it skips over leading white space. This is now leading white space, and therefore allows us to enter a new number. Yeah. So the takeaway from this is, if you have something like this where you only really want one individual character, or only really consume one individual character, but there's a chance that the user enters more than that character that you're looking for, flush out anything up until the new line that the user might have entered. Yeah? Okay. Yeah, this is an interesting slide. This slide talks about why you want to check for whether the answer is different to y instead of checking whether the answer is equal to n, whether the first character of the answer is equal to n. The reason is, well, there's a general idea behind it. The general idea is that you want to write your program so that it is hard to use it wrong. Yeah, it should be easy to use it right. It should be hard to use it wrong. So if some critical operation of some machinery hinges on the answer to a question, then if you're not doing that critical operation unless one specific key is hit, that's the logical choice. If, on the other hand, you would just keep from doing the critical operation if one specific key is hit, and continue with the critical operation if any other key is hit, then you make it really easy for me to drop my markers on the keyboard accidentally and trigger that critical operation, right? Yeah? So, if we imagine that based on the input here, something critical is triggered, then we should keep in the loop as long as the specific key to start the critical operation isn't hit. And only with that specific key should we actually go into that critical operation. Now, we're not in a context here where the answer would be critical in any way, but now just imagine for a moment that this part or this piece of source code would be in such a context. Yeah. So again, to make this long story short, think about how does your program do the least damage? Or how does the program make it the least uncomfortable for the user to use it? I mean, or maybe there's too many negations in that. The most comfortable to use it. Yeah? The least damage and the most comfort. Okay, when you want to mix the extraction operation and the cin.get, or I mean, not just on cin, the .get member function or any input stream. When you want to mix them together, you have to watch out for something. You always have to keep in the back of your mind that the extraction operation, it reads up until white space, but it puts the white space back into the input stream. What that means is, if you have an extraction, it reads data up until a space, for example, puts that space back into the input stream. If you have a get member function call right after that, you get the space. Yeah? So that's important to remember. And here's an example that should illustrate that. It prompts the user to enter a number. User has a chance to enter the number here. Prompts the user to enter a letter. And then does this cin.get symbol in order to get the letter. But what really happens is that we will see the prompt enter a number. The user has a chance to enter a number. And then we will see the prompt now enter a letter. And the program won't even halt for you to enter the A. I think this here won't happen. Because there is still, you hit the enter key here. There's still that character in the input stream. So this member function call here can proceed without waiting for any more input, because there is still that input in the stream. And so you won't have a chance to even enter the A here. Yeah, and you will have 21 in number, and you will have the new line character and symbol. There's different ways to get around this. Of course, you could also extract. Remember, the extraction operation skips over leading white space. So in this case, after reading the 21, it did read the new line character, put it back into the input stream. Now, if we run into an extraction operation, that extraction operation is going to skip over leading white space, which means it's going to skip over the new line, and then we have a chance to enter another character. So that's one way to fix it. Another way to fix it is to use the function newLine that we used in the other program just a few minutes ago, which flushes up until the end of the line, including the newLine character. So that's another way to fix it. Before I continue with this, let's summarize this. When you combine extraction operations followed by get member function calls, then you're going to have to think about the white space that might still be in the input. Yeah? You're going to have to think about what needs to happen with that white space. Should that just be flushed out, or should I maybe, instead of using the get member function, should I maybe use another extraction operation? That depends. I mean, the answer to that question depends on the situation, the specific context in which you are. Okay, any questions or doubts at this point? Okay, so we've already talked about how to consume all the data in a file using the extraction operation. That is, using the extraction operation, that's a high-level I/O operation, high-level input operation. Now we're here talking about character I/O. We're talking about low-level input and output. So here we also have we have another way of detecting whether we have reached the end of the file. And that is the EOF member function of the input streams. EOF, a member function of every input file stream. EOF is short for end of file, and it will return true. Yeah, this is a bit vague here. It will return true when the end of the file has been reached. What will happen is the following. You're using the get member function in order to try to get another character from the input stream. If there is no such character, if you've already consumed all the characters and now you're trying to get another one, that's when the EOF is set. Yeah? That makes the EOF come true. And then if you test for EOF, you will get the true. So you will get true if an attempt has been made to read beyond the last character in the file. Yeah? That's more precise than just when the end of the file has been reached. It's actually the attempt to read something that's not in the input file that makes the EOF come on. And every get on an input file stream that did find another character, of course, makes the EOF be false. Okay, so, and yeah, it's normally not used with the if, it's normally used with a while. So normally we control a loop with it, while not in stream.eof, which you can read as while we haven't reached the end of file of this input file stream. In this loop, we read each character and we write it to the stream. So, an attempt to get the next character, if that didn't trigger the EOF to come on, so if that character was actually in there, if there was at least one character, is what this is, then we go into this loop body, we insert the character red into cout, and we try to get the next one, which takes us back up to the condition. Well, if that next one was there, we go into the loop body again, and so forth. Yeah. So here it says, the instream.eof becomes false when the program reads past the last character in the file. Yeah, this is not needed. Okay, now, I've already given you a little clue about this, but we have two methods to test for the end of file. If you have two methods to do something, the question is always, well, which method should I use in the specific situation I'm in? So, when you're dealing with low-level input, when you're using the get member function, most likely you want to use the EOF member function to test for end of file. When you're using more high-level input extraction operation, then this is the way to test for the end of file. When you combine both, well, then the question is more difficult to answer. Then it really depends on the particulars of in which sequence does this need to take place. Yeah. Okay. In this program, we read every character of a file called cad.dat, and we copy it to a file called c+ad.dat. The only exception to this rule is that every capital C that we encounter, we replace it with the string C++. So the idea is we change an advertisement for the language C into an advertisement for the language C++, simply by exchanging every occurrence of a capital C with a capital C++. Obviously, that algorithm will break down if we have sentences beginning with a word that begins with a capital C. But in this particular example, in the input data that we have, it's going to work. Okay, so we have a function add++. It has two parameters. Both of them are streams. The first one an input file stream, the second one an output file stream. And remember, they have to be passed by reference. The precondition is that in-stream has been connected to an input file with open, and out-stream has been connected to an output file with open. The post-condition is that the content of the file connected to in-stream has been copied into the file connected to out-stream, but with each capital C replaced by capital C++. So here's the call. It only happens after the attempts to open the file. That should be boilerplate by now. And here's that function that we're interested in. We have a single character variable next. We try to get the next character from in-stream. We check, was that get that we just did, was that a get beyond the end of the file already? If not, well then we got something, and we need to check whether it's a capital C. So if it is a capital C, well then instead of the capital C, we want to output C++. So we insert into outstream C++. If it is not a capital C, well then we insert whatever we got. And then we try to get the next character, and that repeats. Test, did we get something, or was that an attempt to read beyond the end of the file, and so forth. So if the input contains, C is one of the world's most modern programming languages, and so on and so forth, then we get C++ is one of the words, and so on and so forth. Observe that all the spacing, all the new lines, and so on and so forth, all that is remains unchanged. It's just the C converted to C++. So with what we know about the extraction operation, we could not achieve that with the extraction operation, because the extraction operation just extracts entire chunks of data. In this case, we would be able to extract entire words, but we wouldn't know whether a space or a new line or several spaces have separated those words. Okay, up to here. Any questions or doubts?
What we're doing with these end files, what we're doing is trying, because this reminds me of one of the contest problems that we have.
Yes.
That was that we had to change sentences by moving the words in reverse. But is this like part what we're just doing is changing, is putting new information for each line depending what character we're putting, right?
Yeah.
Okay, because I'm still getting confused in what's still the difference between the get in into the sin get.
Yeah.
Along with the extraction of the.
Okay, the difference is that with the extraction operator, you're working at a high level. The extraction operator is the goal for it, the purpose for it being there, is to do high level input. Input where you get an entire number, for example, an entire double value from the input, or an entire integer. You can, of course, also use it to extract individual characters. But by design, the extraction operation uses white space to separate the chunks of input, which makes sense when you deal, when you think about the context we deal with numbers. Yeah? Numbers separated by spaces, and you don't care whether two numbers are separated by one space or by 15 spaces or by a space, a tab, and a new line all at once, right? You just want the two numbers. But when you're dealing with input where the user enters something in lines and you want to keep the formatting the same, then you need to know what separates those words. You need to know, is it a space or is it a new line character that separates those words? And therefore, you can then use the getMember function, because that gets every character, including all the spaces, all the new lines and everything, and then you can decide how to work on those. Okay, we have some character functions. Some of those functions are for classifying what kind of character it is. So the characters have been classified into certain groups. There are the digits, there are the white space characters, there are printable characters, and so on and so forth. Yeah, so there are different categories of characters. And to make your work with characters easier, there are these character classification functions already in the library, and you can access them by including the include file cctype. And well, this isn't the character classification function, this is a character conversion function. ToUpper, some of you have already used it. ToUpper is a function that when you call it with a lowercase character, it gives you the uppercase equivalent. It returns a value, and that value is a character, the uppercase equivalent to the lowercase character with which you call it. You call it with anything that is not a lowercase character, while you get that same thing back. Yeah? So it only changes lowercase characters to uppercase characters and leaves everything else unchanged. Only works on individual characters, not on entire strings. So if you need to, for example, turn to uppercase an entire word, you're going to have to write a loop that loops over every character of the word and calls the function ToUpper on every character of the word. It should be, you should already suspect it. Where there is a ToUpper, there is also a ToLower. That ToLower is the complement, so to speak. You call it with an uppercase character, you get the lowercase character equivalent. You call it with anything else, remains unchanged. So there's a little, well, a little quirk to know about, and that is, unfortunately, the data type for ToUpper and ToLower is integer. The data type, the return type. Yeah. You remember the possibility of converting an integer to a character and vice versa? Well, that's what you're going to have to do. You're going to have to force the C++ compiler to pretty much convert the return value of the call to ToUpper to a char, because the type that we get is an int. So if you just insert the return value of the call to ToUpper, it prints an integer, it prints the number 65. One way of remedying this is to introduce an extra character C to assign the return value of ToUpper A to that character, forcing an automatic conversion, and then to use that character C to insert it into the output. Another way, of course, is to use a static cast. That's more wordy, but it also does the job. Okay, this is one of those character classification functions that I mentioned earlier. Is space. All those character classification functions start with is, So there is an is space, there's an is digit, there's an is alpha, there's an is print. All these to check whether a character belongs to a certain group of characters. Is space will return true if you call it with a character that is a single space. It also returns true if you call it with a character that is a tab. It also returns true if you call it with a character that is the \n, the new line character. So, for example, if you want to replace white spaces with dashes, you can have this if-else here. If is space of next, then insert instead a dash, else insert the character itself. So that would replace spaces that you're I mean, if we imagine that this next is the next character from the input that you have obtained, in this case you would read the input and replace every space with a dash. And there are more character classification functions here. Well, this we already talked about. There are some more here. There is an is upper to check whether a character is an uppercase character. In the same fashion, there is a is lower to check whether it's a lowercase character. Is alpha, is it an alphabetic character? Is it something not an exclamation mark or a comma or a period, a semicolon, a digit, white space character? Not any of those, an alphabetic character. Is it a digit? Space we already used. So, to conclude this, who thinks that you know how to write code that reads a line of text and echoes the line with all the uppercase characters deleted? Who of you thinks that you know how to approach this? You're on the right track. You're definitely on the right track, and I think you spotted what's the core to the problem, but it's not just that. There's a little more that you have to wrap around this in order to make it work. So, first of all, read a line of text. Remember how to do that? And well, maybe even before that, before that you want to decide whether you want to use high-level input operations using extraction or low-level input operation using the getMember function. Which is it? GetMember function. Why would it be the getMember function?
Because we want to check each individually. It says a line of text, so we also gotta interpret the other stuff other than just the.
Yeah. Okay. You're right. The line of text. If there are two words on that line of text separated by a space, we need to output that space. If there are two words on the line separated by three spaces, if we should echo the line with only the uppercase characters deleted, then those three spaces, they're part of, they make part of what we're not supposed to touch. So the output should have those three spaces in it. So we need to know what separates the characters of the words. Okay, so the getMember function is what we need to use. And how will we use it? Gonna have a loop, right?
Yeah.
Gonna have a loop. Maybe a while loop. What would be the condition for the loop to continue?
As long as there are like capital letters to continue
No, that loop takes care of read a line. At that point, I mean, whether it's an uppercase character or not, we're going to have to deal with that inside the loop body. Right? Because we're going to have to do something with all the characters. Those that are not uppercase, they're going to have to go into the output. Those that are uppercase, we're going to have to delete them. So, but every character has to be dealt with. Every character has to be looked at. When are we done? No. Not at the end of the file, at the end of a line. What marks the end of a line?
Period.
Nope.
Enter.
New line character, exactly, enter. So, as long as we're not at the new line character, we need to keep going. So, while this next character is not the new line character, and of course, in order to be able to have a meaningful test here, we need to have a meaningful value in next. Where do we get that from? Well, we need to get it. Before. So we need to have a call to the member function get before we can do this test. So if it's not the new line, then what do we need to do? Do what with the uppercase characters?
Delete.
Okay, how do we delete an uppercase character?
It's delete them, not put them lowercase, is it?
Hmm?
Is it deleting them?
Well, what does it say?
Delete.
Delete.
I don't know.
Hmm?
I don't know how to.
You don't know. Well, if everything else goes to the output, deleted characters don't. That's how we delete them. Right? We copy everything to the output,
as long as they're
just
not
not
uppercase.
those that we're supposed to delete.
As long as they're not uppercase, we'll just not write them on.
So how do we do this now? Anybody?
Like what we're doing is that there were like a word like a lone uppercase instead of having the H, we just start with E, right? Or can we just replace a lower H?
No. We don't replace the uppercase with lowercase characters. It says it will read a line of text and echo the line with all the uppercase characters deleted. So it echoes the line without the uppercase characters.
Oh, you just the ones that is up.
Exactly. So something with is upper.
If is upper.
If is upper of
We should use lower.
no.
No? Wouldn't it be easier though?
No. An exclamation mark, a comma, is that an uppercase or a lowercase character? It's neither.
Okay, you're gonna get what?
It's neither uppercase nor lowercase. A comma is not an uppercase character and it's not a lowercase character. So if we would do something with is lower and we would only output those that are lowercase character, we would suppress something like a space or a comma and those things. So you're right with your first idea. We really should check for uppercase. And if what is an uppercase? Which one? Next, yes. Next. If that is uppercase, then what do we do?
Not.
Huh? Nothing, really. Yeah. So let's negate that. If it's not an uppercase character, then what do? We insert it into the output. And that takes care of that. Satisfied? Okay. Can you describe two methods to detect the end of an input file?
EOF.
EOF is one of them. But can you describe it? Who can? Somebody? Can somebody describe that?
EOF checks all the characters until it goes past the last character.
Yes. When you have attempted to read past the last character, then you call the EOF function, it will return true. Otherwise, it will return false. And the other method? No, that was what she just said. The get and the EOF. Yeah, but the other method, that's also still the get and the EOF. Anybody? No? It was the extraction operation, and using the extraction operation, the expression formed by the extraction operation as a truth value to control a loop. Remember? While in-stream extracted to next. We had that earlier. And that reads entire chunks of information, places them in the corresponding variable, for example, the variable next, and that can be an integer, for example. And so in that way, we can go over all the integers that are contained in the file. And who of you can describe white space? Well, that should be easy.
Anything that's not a character.
Or an integer.
Space, tabs, new lines, yes, right. Okay, and that concludes this chapter. And we only have 4 minutes left, so I'm not going to start another chapter.